In this lesson, we will be discussing how to simplify expressions involving radicals. So I'd like to start off with an example that you all should know, and that's going to be the square root of 2 times 2. Now, we all know 2 times 2 is 4, and the square root of 4 would just be 2. Okay, so nothing too complicated. Now, I'd like to also show another example where maybe we have square root of 2 times 2 times 2 times 2. Okay, so this one would be square root of 4 times 2 is 8, times 2 is 16. So you have square root of 16, which is 4. So the pattern is going to be this. So the index for both of these, if it's not written, is going to be a 2, meaning square root of whatever is inside of the radical. So the pattern that we're going to use for simplifying is we're going to look for groups of 2 since the index is 2. So notice there's a group of 2 right there. There's 2 2's. So for every group of 2, I'm going to pull one of those numbers out outside of the radical. So there's one group of 2, so my final answer is going to have 1, 2. So for this one here, the second example, notice we have 2 groups of 2's. We have a group of 2 there, and then 2 more 2's right there. So 2 groups of 2's. So what we have on the outside is going to be 2 2's that we pull out. So 2 times 2, which we know to be 4. So that is the pattern. So if we have an example that does not work out evenly, say we have 2 times 2 times 2. There's 3 2's. So since the index here is 2, okay, we're going to be looking for sets of 2 numbers. So here we have a set of 2. So for each set of 2, I'm going to pull out one of that number. So we're going to have 1, 2 is going to be pulled out of the radical. But notice we still have this 2 remaining inside. So we're going to keep that 2 in there. So we pull 1, 2 out and leave the other 2 back inside the radical. So your final answer will be 2 square root of 2. And that is the pattern. Let's try one more example. Let's use square root of, let's say, 3 times 3 times 3. And we'll add 2 more 3's, times 3 times 3. Okay, so since the index here is 2, the index is 2, right there. That means we're going to look for groups of 2. So here we have a group of 2. Here we have another group of 2. So for each group that we have, we're going to pull out one of that number. So because we have one group of 3's, I'm going to pull out 1 3. We have a second group of 3's, so I'm going to pull out another 3. And remaining on the inside is a 3, just 1 3. So your answer is going to be 3 times 3, which is 9, times square root of 3. And that's going to be your simplified answer. Now if we have different numbers represented underneath the radical, the same process still applies. The index is an unwritten 2, once again. So we're going to look for groups of 2 of different numbers. So notice we have a group of 2 here, and we have a group of 2 here. So we have a group of 2 3's, so we're going to pull out 1 3, because we have one group. And then we have a group of 4's, so we're going to pull out 1 4, because we have one group of 4's. So your final answer is going to be 3 times 4, which is going to be 12. Now in most cases, the radicand, which is the number underneath the radical sign, will not be factored for you, so you will have to factor on your own. So for square root of 24, what you're going to have when you factor, you will have 2 times 2 times 2 times 3. And now you're going to do the same process that we just did. Since the index is an unwritten 2, it means we're going to look for groups of 2 of something. So notice we have one group of 2 right there. We have 2 2's. There's no other groups of 2's, so all I'm going to pull out is that 1 2, because I have one group of 2's. And on the inside of the radical is going to be the 2 times the 3 right here, which will give me a 6. So your final answer is going to be a 2 times the square root of 6. Now we learned a property of radicals in the previous lesson, where if you have a fraction underneath the radical, you can simplify by breaking up the radical sign, where we have square root of the numerator, which is 3, over square root of the denominator, which is 16. So I'm going to have square root of 3 over square root of 16. So in this case, we're going to have, as our final answer, square root of 3 over 4. So here's another example where I can break it apart again. I'm going to get square root of 1 over square root of 5, which will simplify to be 1 over square root of 5. Now, there is a standard amongst mathematicians where we do not allow a radical to be in the denominator of a fraction. So what we do is we perform a process called rationalizing the denominator, meaning we get rid of the radical in the denominator by going through this process of rationalizing. So we're going to use our previous properties where if we multiply by square root of 5 over square root of 5, notice what I'm doing is multiplying by a fancy way of writing number 1. Square root of 5 over square root of 5 is another way of writing 1. So what I'm going to get when I multiply these together, I'm going to multiply the numerators, which is 1 times square root of 5, over, and on the denominator we're going to have square root of 5 times the square root of 5, which when you multiply those together, I'm going to get 5. So notice what I have. I have square root of 5 over 5. So now there is no radical in the denominator, and this is simplified as far as I can. Another property of radicals says if I have two radicals being multiplied together, that I can combine them into the same radical, where now I have, instead of two separate radical signs, I have one, and I can combine the two numbers that were underneath the radicals into one. So I take this 5 and this 5, put them into one radical, so I have square root of 5 times 5, which we know that to be square root of 25, which would be simply 5. So your final answer would be 5. Now, some cases, I have different numbers, so say like square root of 2 times square root of 8. So when I multiply those together, I'm going to get square root of, now in one radical, I get 2 times 8, which would be square root of 16, which we know to be 4. So your final answer is going to be 4. Now in some cases, it's going to be helpful for you to not take the time to multiply the numbers together. What I mean by that is when I combine them into one radical, I will get 3 times 27. And now instead of multiplying out 3 times 27 getting a number, what I can do is I can just leave it like that, and I can just factor 27 the rest of the way. Instead of taking the time to multiply and then maybe factoring back down again, I can keep it as 27, just factor down the rest of the way. So I can use the same process I used before, where I look for groups of 2 of something. I've got another group of 2 right there. So I'm going to pull out 1, 3 for this one group here. Since I have a second group, I'm going to pull out another 3, 3 times 3, which is going to give me 9. Now that example was not too bad, where multiplying 3 times 27 would not have been too difficult to do, but there are some cases where you want to not multiply out so that you're going to save yourself time factoring later. Now remember I said before you cannot have a radical in the denominator. So if you have this radical given here, square root of 10 over 7, notice the denominator 7 is part of the radical. The whole fraction is inside the radical. So I need to somehow rationalize that, or get rid of that radical in the denominator. So what I'm going to get is I'm going to split these up where I have square root of 10 on the top over square root of 7 on the bottom. And now I'm going to carry on the process that I showed previously, where to get rid of that square root of 7 in the denominator, I'm going to multiply by square root of 7 over square root of 7. So what I'm going to get for the numerator is I can get, in one fraction, I can combine the 10 and the 7 inside one radical, sorry. So I'm going to get that for the numerator. And the denominator, I'm going to get square root of 7 times square root of 7, which if I combine that into one radical, I'm going to get this. So my final answer would be square root of 70 over, and the denominator will simplify to a 7. So your final rationalized, simplified answer is going to be square root of 70 over 7. One last technique that you can use that may be helpful on certain occasions is kind of going back in reverse to maybe make things a little simpler. What I mean is, whereas before I separated the radical into a fraction like this, so now we have two radicals instead of just one with one fraction. What I can do is maybe go in reverse, where now I can put it in one fraction, or one radical like this. So I'm going to get square root of 96 over 3. So why I want to do that is because 96 divided by 3 we know to be 32. So I'm going to get square root of 32 now, which is no radical in the denominator. This is much more beneficial for us. And then from here we can simplify the rest of the way. I must pull out everything that I can. So 32 can factor down, where I'm going to get 2 times 2 times 2 times 2 times 2. There should be 5 2's underneath. And since the index is 2, it's not written as 2. I'm looking for groups of 2 of things, so I have a group of 2 there, group of 2 there, 1, 2 left over. So I'm going to pull out 2 2's because I have 2 groups of 2's left over with 1 2 in the middle. So I'm going to have 2 times 2 is 4 times square root of 2 as my final answer. One final example here is if I'm trying to multiply a combination of radicals and numbers together. What I would want to do is simply look at the number parts and multiply those together. So just the number part without the radical, the 2 and the 4, I can multiply those together and get 8. And then I'm going to multiply the radical parts together, so the square root of 3 and the square root of 3, multiply those together. So when I multiply, I'm going to get square root of 3 times 3 in one radical. So we know that to be simply 3, so I have 8 times 3, which is going to be a 24. And that's going to be your final answer.
Made with Doodlecast Pro.